Okay, class 10, good morning. Chemistry. Okay, pay attention to this, please. We were doing stoichiometry. Okay, we were doing the numericals in that, the Avogadro law and all that stuff that we had. We'll be doing that again when the school reopens. Okay, we'll be back into that chapter once more, doing the numericals and all. But for the time being, let us complete this chapter. We haven't done this percentage composition and empirical formula. Now, percentage composition is something very old. You have already done it in class 9. Okay, I'll just give a fast revision of that. Okay, suppose they ask you for the percentage composition of the elements of sulfuric acid, H2SO4. Okay, percentage composition of the elements of sulfuric acid. Okay, now how do we go about with that? Sulfuric acid. Okay, now atomic weight of hydrogen 1, atomic weight of sulfur 32, and atomic weight of oxygen 16. Now this you don't have to worry. As I said, this will be supplied to you. You will be getting this. Okay, so you need not worry about the atomic weight. Now what I do is I find out the molecular weight of this. Hydrogen, okay, 1 into 2 plus, sulfur 32 plus, oxygen 4 into 16, 64. Got that? Right? Now when you add this, I think this will work out to 48, okay, 98. So the total molecular weight is 98. Got it? Now, what is the percentage of hydrogen? 2 over here. So 2 is what percent of 98? 2 by 98, this is hydrogen. 2 by 98 into 100. What is the percentage of sulfur? The atomic weight over here, according to this, is 32. So 32 is what percent of nitrate? 98. 32 by 98 into 100. And oxygen accordingly, okay, this is sulfur, and then comes oxygen. Oxygen is 64. So 64 is what percent of 98? Got it? As simple as that. Okay, here what I'm doing is I'm finding out the percentage of all the elements of sulfuric acid. They might ask you only for one. They'll say, what is the percentage of sulfur in sulfuric acid? So in that case, you do only this much. Okay, but if they say find the percentage of the elements of all of them in this particular compound, then you have to find out. Well, generally they don't do that. They'll ask for only one of them. Am I clear with that? Okay, you have done this in class 9. This is a class 9 revision. I was doing this thing in class 9 just now. Okay, so much about your percentage composition. Very, very simple. Okay, fine. Now we go on to empirical formula and molecular formula. Okay, now I think I did that in class. Molecular weight is equal to 2 VD. Molecular weight is equal to 2 VD. I did this relation in class. Okay, now we go on to the numericals. Check, this is also very stereotype. Okay, you have all tables and all that. You just follow the table. Simple as that. The percentage will be given to you. Percentage composition will be given to you, and you just need to follow that. Okay, check this out. Alright, here it comes. Look at this table. 1 is enough. Just look at this table over here. Okay, look at this table here. Now this will be given to you. Okay, as the question goes, the compound is found to possess carbon 40%, hydrogen that much percent, oxygen that much percent. Might happen that they have not given you one of the percentage. So what you do is you just subtract it from 100 and you get the rest of the percentage. Got it? Now, so carbon, you make tables like this. simple tables: carbon, hydrogen, oxygen. Carbon 40% given, hydrogen 6.7, oxygen that much. This atomic mass, again I said, will be supplied to you. Atomic mass of carbon 12, hydrogen 1, oxygen 16. This will be given to you. Okay, now what you do, the atomic ratio, look at the atomic ratio. You divide the percentage by atomic weight, percentage by atomic weight, percentage by atomic weight. So what do you get? 40 by 12, 3.3, 6.7, 3.3. And now what you do is, out of the three, okay, out of the three, you multiply it by the smallest of them. Now, which is the smallest over here? 3.3. Of course, there is 3.3 and 3.3 over here also. So that's okay. Did you get that? So when you multiply that, okay, you will be divide, not multiply. You divide 3.3 by 3, 3.3 by 3, and 6.7 by 3. So you get 1, 2, 1. You divide by the smallest of the three. Divide by the smallest of the three. Okay, and you'll get a simple ratio here, the simplest ratio. So your empirical formula is C1H2O1. Did you get that? I'll repeat that once more. Okay, percentage composition will be given to you. Atomic mass is given to you. We divide the percentage composition by the atomic mass, okay, and you get these values. Then you divide by the smallest of the three. In this case, it is 3.3. So 3.3 by 3, 3.3 by 3, by 3.3, and 6.7 by 3.3. So you get this. So your empirical formula is C1H2O1. Now, they have given you the molecular mass over here, 60. The molecular mass is supplied 60. So, N into empirical weight, N into empirical weight is equal to molecular weight. I had talked about this in class. Okay? So, I need to find out this N. This is given to me, 60. Okay? N, molecular weight, C1H2O1. So, N, okay, 12 plus 2 plus 16 is equal to 60. Okay, so this is 28 plus 2, 30. N into 30 is equal to 60. Okay, so N is equal to 2. So your molecular weight will be N into this. Okay, so 2 into this. So C2H4O2. Your molecular weight will be C2H4O2. Did you get that, everybody? As simple as that. Okay.